let's review here just really quickly a couple things, some of the special factor forms. And we talked about these already, but I wanted to reiterate that they won't always be a leading coefficient of 1. There might be some different numbers that are out front. So if that's the case, the same general rule will apply. Okay? The first special factor form is the difference of squares. If you have a form a squared minus b squared, it will always factor into the sum and difference of those bases being squared. So the bases a and b be the sum of them times the difference. Okay, so looking at this example here, can we express each of these terms as a perfect square, a base that's being squared? What base would you square to get 49x squared? 7x. And what base would you square to get 16? 4. And so when you look to factor these, it factors into the sum and difference of those terms. So 7x and 4, it's the sum times the difference of those terms. Okay, so again, even if it's not a leading coefficient of 1. Okay, in a similar way, the perfect square trinomial does not have to have a leading coefficient of 1 either. Okay, and what you need to be able to recognize is if your first and last terms are both perfect squares, and if you take the bases that are being squared and you double the product of those bases and you get your middle term, it fits this pattern of a binomial square. So again, kind of looking at this example here, 36x squared is the base 6x, quantity squared. 25 is the base 5 squared. If you take the product of these two bases and double it, do you get this middle term's value? So 6x times 5 is 30x. When you double that, do you get 60x? Yes. So what that means is you have a binomial square, the first term of 6x, a last term of 5, and the sign for this is always going to be whatever the sign of your middle term is, so a negative. And so those would be the special factor forms as they would apply if your leading coefficient is something other than a 1.